Yes, coming from you from live from Prague, broadcasting via satellite. Wouldn't that be cool? Yes, let's send out a message to our alien friends out in the galaxies. Hey, Mr. War here, not a green, really kind of ugly looking green guy with teeth that look pretty sharp and jagged. No, this is Mr. War and we're here for math and you guys know that, so let's go ahead and move on down, bring down this curtain and see what we got hidden. Oh, it's a bright green. I like that color. I do. It's nice and bright and green. Yeah, and it's a new topic. If you notice, we are moving on. Yes, you guys are getting ready. We're about halfway through this module, believe it or not. We're doing topic C, as you can see. I tried that. Making like units numerically. And numerically is just a word that basically means number, right? So we're going to be doing something with a number line. Today, yoo-hoo, yeah. Okay, bring this down. So let's carefully look at our objective here. Our objective is students will be able to add fractions to and subtract fractions. Okay, add fractions to and subtract fractions from whole numbers using equivalence and the number line as strategies. Wow, that's really heavy, dude. Yes, that's going to be our objective today, so we'll be doing a lot of that. And if that objective kind of confused you a little bit, you shall see as we refer back to it that it's really a little bit easier than it appears. Now, here's our application problem. Let's see, I'm trying to think what this guy's doing here. Yeah, out of my way. Okay, thank you. He was kind of bothering me there. Okay, it says Silvana found money in her pocket. How nice is that? She went to a convenience store and spent 1/4 of her money on chocolate milk. Doesn't sound healthy, Silvana. 3/5 of her money on a magazine. Of course, it was Science Daily, I'm sure. No. And the rest of her money on candy. Uh-oh. All right. Don't worry, Silvana. We're not going to tell anybody, okay? Although this is on YouTube. I don't know. What fraction of her money did she spend on candy? Okay. Very interesting problem. All right, let's go ahead and try to solve this problem then by taking a look at this. First thing I'm thinking is that, that R, D, W, the read, the draw, and the write. And I'm reading this problem thinking to myself, there is some important information here. Basically, that she has spent 1/4 of it here on chocolate milk. And 3/5 of it on magazine. And then the rest of the money. So I think the thing that's significant and important in this problem is the fact that we're not going to know how much money she actually spent, because all these numbers have been given to us in fraction form. So basically what we're going to do here is we're going to show our problem. We could use this tape diagram. I always like that. Let me go ahead and get red. Red works for me. Red. So we could say that entire whole right there is Silvana's money, which you can see I got my little label already set up for that, right? So that's Silvana's money right here. It's the whole, okay? We don't know how much that could be. It could be $10, $9. It could be $300. We just don't know. But it's not asking us. It's asking us what fraction of that money did she spend on candy. So this is what makes me want to take out my pen again. Let me go ahead and can I get blue for fun? So, 3/5 is a little bit more than half, isn't it? And 1/4, of course, is less than half. So I'm going to start off with my little one first here, my 1/4. So if this was half, I guess this would be about 1/4. And I'm just kind of estimating. It doesn't have to be perfect. Okay, this is what she spent on chocolate milk. And we have the milk right over here. Milk, grow and get big. There you go. So we're going to take that and we're just going to, I'm going to put that on the inside. And we'll go ahead and put that this was the 1/4. Okay, and now we also have all these colors. It's making my mind go crazy. And 3/5 is a little bit more than half, so it's not going to be 1/4 and half. So it's going to be actually a pretty big chunk here. I'm just estimating, but that's about right. And then we're going to have to come over here and say that's what she spent the 3/5 on, was the magazine. So we'll put that in there. And again, this is just a tape diagram. Here we just don't know. This is going to be the candy, all right? And we don't know. I'm just going to actually write that in faster. And this was our 3/5. So we don't know what that fraction is here. That's what we're lacking. So let's go ahead and bring this on down, okay? I'm looking at this saying, okay, so that would mean then at least 1/4 plus 3/5 plus whatever the candy is going to have to all equal 1, because this is our 1/2, okay? Our 1/2, whatever that money is, but in a fraction, it's going to equal all the money that she had from the beginning. Now, looking at this, I can see that I need to add these two fractions. Of course, they don't have the same denominator, and that's always a problem in math when we don't have the same denominators. I know, it's just not very cool. And so I would say that we should probably get a common denominator here. Now, if you recall, we used to, when we were adding fractions that were unlike each other, what we were doing was, we were basically, whoa, what happened? Come back. Okay, so I'm going to go ahead and try to make these the same size. Oh, am I good or what, huh? See, so I have 1, 2, I have fourths here, and I have fifths here. And what we were doing was, we were taking a look at it, and we realized that, if we could break up the units so that they're equal in both fifths and, in this case, fourths, that we could then add the fractions together. And as you can see here, it's making 20ths, because we have 5 going in this direction and 4. 5 times 4 is 20. I'm just kind of showing you that. I'm not going to use this time around, but I want to kind of remind you that that's what we were doing. We were basically taking a look at how those fractions, the unit fraction, was broken up inside that whole. So this kind of leads me to something I can do here now. So this really in reality is, and hang on because the ride might get bumpy here. So this is really saying like 1/4 times, and because we were breaking that up into fifths, this is really just like saying times 5. Because that quarters, when we put that on top, we are multiplying it by 5. Of course, we're going to go ahead and also put a 5 up at the top. Okay? Because what we're going to end up doing here is we're going to be doing 4 times 5 is 20. Well, then what you do to the denominator, you also have to do to the numerator. Okay? And then we're going to go ahead and add our 3/5. And since our 3/5, let me put this here, is going to be times 4/4. Okay? And again, you may be asking, how did I get that? Well, if I'm changing these unit fractions into 20ths, that's like I'm changing those two fractions, okay, like so. Now, in order to get that fourth to turn into the 20th, I'm multiplying that 4 by 5. We put the 4 times 5, okay, is 20. So then we'd have to get that new fraction, we'd have to multiply him by 5. And this is what I've done here. Does that make a little bit more sense, I hope? So now if I go ahead and I continue with my math, you can see I get 5, because 1 times 5 is 5. And then we'll go on the bottom here, and 4 times 5 is 20. And that's just what we were doing before. I'm just showing it in a new way here. And now we have 3 times 4 is 12. And then, of course, 5 times 4 on the bottom is 20. Okay? Now we have our new unit fraction of 20th, so I can add those together. And you see I get 17/20. Now 17/20 is if you add the milk and if you add the magazine together. It doesn't tell us yet what the candy is. However, if all the money that Silvana started off with was just that 1/2, we could take the 1/2 now and we could subtract the 2 add-ins that were here so that it will get us to the candy. And so, that being said, we really could then write it out this way and put 1, then minus, well, or let's put it this way, 17/20 is the same thing, plus the candy is going to equal that 1. So now I've already gone here and said 1 minus 17/20. Well, how many more would we need to get to 20/20, which would equal 1 whole? I'm thinking probably a lot of you are going, yes, 3/20, Mr. Wara. 3/20 because 17 plus 3 is 20. 20 over 20 would equal 1. So therefore, the candy, the fraction of money she spent on candy, was 3/20. Yes, I like it. I do. Yes, I do. So let's go ahead and go on to our next problem. Oh, we have Happy Feet Guy. Oh, my goodness. Yay, you're looking pretty, kind of ragged. Happy Feet, what happened to you? Oh, my goodness. Or are you Lovelace? You looking like Lovelace, huh? Wow. My goodness, you kind of look like you lost your flipper right there, but okay. Just stay right there. Please don't move. Because you know what? I actually have something I have to do. I have to put this there. Sorry. Okay, make that a little bit longer so there's no confusion. All right, so let me go and take a look here. It says, think to yourself what addition problem would match this picture. So I'll go ahead and get a pen here so we can kind of keep moving on down. So, and you can think to yourself, I'm going to think to myself. I see this box here, okay, plus there's like another box. They all look like equal boxes, so I would say that looks like it could be 1 whole plus, and then it looks like I have 1 whole, and then I have 3 out of 4 shaded here. So it almost looks like that I have 1 plus 1 3/4. Yeah, I like that. I think seems pretty simple, okay? Well, we're going to come down and show this like we were doing with boxes. Now we're going to show this on a number line. As you can see, I have my number line all set up, ready to go. So I'm going to go ahead and start marking my number line. And how I mark my number line? Well, when we usually start counting, if we're adding 2 numbers, we could show this quantity 1 plus 1 3/4. I mean, we'll start off with 0, since we're going to use that first add-in. Okay, and I don't know how large this is going to get, but let me just go ahead and put a 3. I don't think it'll be bigger than 3. So if that's 3, then this would be 1 and that would be 2. Okay, we're okay with that, I hope. And so then I'm going to go ahead and maybe I need to show my first add-in going to 1. Seems pretty simple. So let me go ahead and do that. I have my arrow. Well, I have my arrow. Come on, arrow. Thank you very much. And I need you to stretch. There you go, stretch. Good job, buddy. Okay, so that gives us our first one, right? Let's say that's like a little +1 there. So we have our 1, which is right here. And now we're adding 1 3/4. Okay, well, I can go ahead and add that 1 part first. And I'm just going to actually use this guy since he's about the size I'm looking for. Pretty close. Perfect. Okay, so now I have another like little +1 there. And you can see now I have 2. Cool. But I have a 3/4 here too. All right, so I'm going to have to do some work here. Oh, wait. So that would be like 2.5 right here if I put that in the middle. So that would be 2 1/4, 2 3/4. And that's what I need to do is I need to add 3/4. So I'm going to kind of do this here. I think I'm going to do this with my pen. This I'm using yellow. So it's almost like saying we're going to do 1/4. See? 2/4 and 3/4. So now we have 3/4 here. I mean, my answer is going to be 1, 2. Well, looks like 2 3/4. Wow, is that easy? I thought it was pretty simple. Myself, anyway. Where are we at here? Yeah, this next one is going to be this. That's right. That's right. Just what it looks like. I don't know, maybe I'll help you out. Just make sure there's no confusion. That's what we want. And I'm going to just do that. Goodbye. And goodbye. And next page. So let's do another practice one. We have 1 whole minus 1/4. Showing again this on the number line. It's really important that we know how to do this. Now what's interesting about this particular problem is taking 1 minus 1/4 is, well, we're not adding. Well, our number line isn't going to be going to the right like we think. So I mean, we can still start off at 0, but we're going to be subtracting, so maybe we want to have our 1 over here. Is it just me, or is he following us? I don't know. Yeah, you're like following us, huh, buddy? Okay. Mr. Aurora, really? You could take that mess off him. Thank you for being nice about that. Sorry, buddy. Okay, I should have just moved you nicely. Please move out of the way. How about that? Put you down here. Now, back to our problem. Back to our regular programming. 1 minus a quarter. Okay, well, we need to get some other numbers in here. Well, if that's 1, and we are doing quarters, seems to sense that I could put my 2 quarters here, which is, of course, is 1/2. This would be 3 quarters, and this would be 1 quarter. Interestingly, we are subtracting that amount. But we're just subtracting 1 quarter? Is it just me, or does this seem really easy? Uh-oh, my arrow's going like the wrong direction, though. Can I turn them around? Flip. No. Upside down? All right. Sorry, you little arrows, you're not a lot of good to me right now, so I'm going to go ahead and make my own. So if you're starting at 1 and we subtract 1 quarter, there we go. See? Because this is 1 quarter minus 1 quarter, of course, and it's bringing us to 3 quarters. Therefore, this equals 3 quarters. I know what you're thinking, Mr. Wara. This is really easy. See, what were we doing? We've been adding fractions and to and from whole numbers, okay, using equivalence, and that's basically what we've done here with equivalence in the actual. Actually, the next problem is going to deal with this one a little bit more, and the number line as strategies. I think we have one more problem. Whoa! Oh my God! Where are you coming from, man? Where is this guy doing on? Oh my goodness! And he doesn't want to move. He just wants to. Okay. So anyway, I could just delete you. Yeah, sorry. No hard feelings, buddy. No hard feelings. Come on, shake it off. Okay, so here we go with this problem. Now we have 2. Minus 3/5. And I'm going to go ahead and mark this as 0. Let's go ahead and put this as 3, making sure that we have covered. That's 1 and that's 2. And it's pretty close. We'll slide you down a little bit. Come on down a bit. There. Make it a little bit better. Now, here we're going to obviously start off at 2, but we're going to be subtracting 3/5. And I guess there's a couple different ways. 3/5 is less than 1. You could kind of think of this problem, I know this might be confusing, but this is really 1, and then you could think of this as like 1 minus 3/5, okay, because this is 1 and that's 2. That's still 2 minus 3/5, so we're really taking the 3/5 from the 1. I don't know, that might be a little bit too confusing. If it's confusing, no worries. Since we're subtracting fifths, and we're starting off at the 2, well, and the reason why I want to set it up this way is so we take our 1 whole here and break it up into fifths. So if you could think of it like this, 1, 2, 3, 4, 5, that those are in fifths, then we can take away 3/5 within that 1 whole. So we're taking away 3/5, so you figure 1, 2, 3/5, okay? That's what we're taking away. We started off at 2, which was our problem. And now you can see we have 1, 1/5, 1 and 2/5 is going to be our answer. Do we have another problem on here? I think that might have been the last one, right? Yeah, that was the last one on here. So anyway, that I think pretty much, I think there's another way that you could do that. But I think the key thing here is if you do have that fraction, is that you break it up into parts, just like we did with the quarters. I think that pretty much covers it. And I also think that this brings us to this point. And we are done. Yes. Finito. This is it. Till next time.